Thank you very much. What a wonderful introduction. And it is an absolute delight to be back. I remember the 2017 event. It was here in the same place. I came back again in 2019. I loved the country so much. I came back for Iceland Airwaves, actually. And then everything went into lockdown, and the rest is history. Every so often, and I know it's happened to me in my career, and I'm sure it has happened to many of you out there as well, you wonder, why do I do the things that I'm doing? And does what I'm doing really make a difference? Does it really have an impact on things? I think it's healthy for us to be a little bit kind of prosthetic like that every so often. I was lucky enough to meet a gentleman called Simon Pollard. Simon Pollard's the CEO for a company called Covey. Covey produce bionic prosthetics. They have what's called the Covey hand. It's one of the most sophisticated prosthetic hands I've ever witnessed. And I remember talking to Simon about it to say, how did it come about and what role do we play? And he talked to me about it and he said, we're fitting these to Ukrainian soldiers, we're, all of these different things. He said, and you guys are the data behind this. He said, and never underestimate that, because this entire technology is driven by data and making sure we get the data into the technology or in front of the people who can develop the technology. Well, I thought, wow, that's fantastic. What a thing to be involved with. But that wasn't the story that stopped me in my tracks. A few weeks after that, in November of last year, I had the honor of meeting a lady called Sarah de Lagarde. I don't expect many of you will have heard of Sarah, but back in 2021, Sarah had climbed Kilimanjaro. She was literally on top of the world. She had a young family. Everything was in front of her. She's a young lady with an incredible future. A few months later, in November of that year, she was going to work. She left work that evening a little bit later than normal, went to High Barnet tube station, which is her normal tube station to go home. And as she stepped onto the platform, her foot slipped. And she went straight down between the edge of the platform and the train that was at the station. She called for help. It's an unmanned station. No one heard her. And the train left the station. And it took her right leg with it. She continued to lie on the tracks, calling for help, and there was still no one could help her. And another train came into the station, and it took her right arm. I personally don't know what level of courage you have to be able to lie there on the track in that situation and know that somebody's going to come and help you, somebody's going to come and save you. But they did. Simon Pollard found out about Sarah and was just taken aback by her story and wanted to do something to help. So they got involved. They fitted her with a prosthetic leg, they fitted her with a prosthetic arm, and they fitted her with the Covey hand. And in 2023, Sarah de Lagarde climbed Kilimanjaro again. It's the first woman, double amputee, to climb Kilimanjaro. And I had the honor of meeting her. And I remember saying to her, of all of the things that you've done, of all of the things that this gives you back, because nothing could ever replace what you've lost, what's the one thing that stands out for you? And she said, I can hug my children. That, for me, was that moment of, this is why I do what I do. If I can play a small role in doing something like that, in enabling something like that to happen, that makes everything I do worthwhile. And I'm convinced that there are many of you in the room that maybe don't have that level of connection, but the more you think about it, the more you realize, actually, there's some group that are benefiting because of the things that I do. And that's what fascinates me. So anyways, always nice to start off with a joke, right? They said keep it light. I thought that was quite a light story. So I wrote a book called The Fourth Wave. It was never intended to be a book, and I'm not going to sell the book very well because I was never a very good writer. And over the last 10 or 15 years, I didn't pass English literature at school. I didn't pass English language, actually. But over the last 10 or 15 years, I got better. I was writing blogs, writing LinkedIn posts, and I improved. And then about 2 or 3 years ago, I just had all this stuff in my head, and I thought I'll write it down, because I don't know what it'll be, but it's better out there, it's better written down, because then I might use it for something than just sat in my head. And I started writing, and 70, 80, 90 pages later, I'd still carried on writing. And what fascinated me was going through that process was you then start to spot patterns. And that's how this all came about. So when I think about my time in IT, which has been since, I've been working for NetApp since 2005, so I'm 19, almost 20 years with NetApp. I've been in the industry for a little bit longer. This is what it made me realize. We have to ride the ripples, we have to manage the ripples and ride the waves. Because there's technology advances happening every single day. Every day we see quicker networks, new processors, denser solid state drives, bigger memory. And all of these things are really, really important, but they kind of we have to engineer them into our business. They're things that we just have to do in order to keep at the front of technology, in order to benefit from technology. But most of those kind of things don't fundamentally change your business. They don't fundamentally make a huge difference. They're ripples. But then we get waves. And waves create hundreds of billions, if not trillion-dollar opportunities. And I've seen 4 of them in my career. The first one was the move from kind of monolithic type technologies to modular mid-range technologies. I'm sure many, well, I say I'm sure many of you, there's a lot of young-looking people in this room. I'm sure a few of you remember IBM Sharks, HDS Lightning, EMC Symmetrics, these big, very, very clever, capable pieces of technology. But the world was changing, and vendors like ourselves kind of came into this world in the 90s and said, that's the way we've done things in the past, it won't be the way we do things in the future. And we saw this massive shift from monolithic to more modular mid-range type technologies, or even client-server. But behind the wave was what really excited me, because I sort of spotted this pattern. We do these same 4 steps every single time a wave forms. We typically see that it's happening, and trying to identify a wave is a topic for an entirely different discussion. But what typically happens is a company sees that something significant is occurring. And we all like to think that we take a very strategic approach to how we embrace this wave. We don't. We see a wave occurring, what happens is everyone goes, boom, because lots of different groups, different departments can see the value that this thing could provide to them. In this wave here, for the few of you in the room that will remember, when we went to modular mid-range technologies, the Exchange team built the Exchange infrastructure, the SAP team built the SAP infrastructure, the Oracle team, the Oracle infrastructure, the SQL team, the File Services team. And they all made a decision to use the technology that they thought would be best for their application. And we saw huge innovation. Companies suddenly saw this, were inundated with new applications, new technologies that they hadn't had access to before. And there was a big wave of innovation that came. But what was once new becomes normal. And over time, the impact of this thing starts to diminish because we're all doing it. And it's usually at that point we hit step 3, which is we look out across what we've built and realize we've built a monster. I don't call data centers data centers. I think data centers are typically a museum of past IT decisions. And it's for these very reasons. So you hit step 4. How do we simplify, standardize, automate, optimize, consolidate? How do we simplify the beast? Because guess what? There's another wave coming. The second wave for me was virtualization. I'm fascinated by this. Hands up if you remember the world before virtualization. Take a look around. It's about maybe half the room. And thank you to the half of the room for making me feel a little bit younger than I did before I came out onto the stage. It doesn't feel like that long ago to me. It was probably 2007, 2008 was before we saw the really big explosion of virtualization. But I'll tell you now, we went through these 4 steps. Anyone remember Citrix, Hyper-V, KVM, VMware, and a whole bunch of technologies that no longer exist today? And we used them all. Because different people could see the value of different virtualization technologies for their part of the business. And what was once new became normal. The initial value, the initial innovation that created suddenly diminished, and we built another monster. And a lot of companies typically standardized, there are exceptions, onto Broadcom and VMware. And then another wave came along. Cloud. Different people are at different stages of the journey. But with cloud, again, we've seen the same pattern. The developers like AWS, the AI teams like running Vertex AI inside Google, the people who are paying for it like Hyper-V because they get good licensing agreements, et cetera, et cetera, et cetera. And we're starting to see that same thing again. The cloud has brought huge innovation with it, but as people see that what was once new becomes normal, and that innovation level subsides with the cloud, we're starting to see the same thing happen again. People realize they've built another monster. But this time it's not physical technology stacks, this time it's technology stacks built within the clouds. And now we have to get ready for the fourth wave. I've made it 10 minutes into this presentation without saying AI. AI, AI, AI. Let's get it out of the way because it's either going to stumble on it. And I think this will be even worse this time, because I think the diversity of different groups and teams and departments that are experimenting with AI and the choices that are available to them to go out and experiment means that people have just gone mental. I talk to companies and they go, we've got 100 AI projects running. Are they talking to each other? No, I don't know. So there is going to be huge value that we see from some of these projects. A lot of these projects are just too much excitement over something that I don't think is going to materialize. I think there's going to be a lot more rigor this year as to, does this really deliver the value we thought it was going to deliver? And if it doesn't, kill it. I think at the moment we're giving people that freedom. We'll see innovation. We'll see what was once new will become normal, and we'll see the same steps that we go through again. And this fascinates me, because if you realize that's what typically happens, would you do something differently because of it? If you kind of knew that we were going to follow this same pattern, would you make a different decision knowing that that's the case? And that's the stuff that fascinates me. So let's start with the third wave. There was quite a set of hands that went up in the room when I asked you, do you remember the world before VMware? For those same people, what word would you use to describe the world before VMware? I'll give you mine: horrible. As a technologist, I loved it. You know, I got a chance to experiment with all sorts of different stuff. But the reality was, it was an incredibly complex world. We had underutilization, we had different technology stacks, we had to back this stuff up, we had to secure it, we had to, honestly, virtualization fundamentally changed the world around us, changed the world within IT, and does continue to. I would put it to you that many of the problems that virtualization solved for us are coming back again. The world of cloud is technology stacks. They're just not the physical technology stacks that we remember. They're the cloud technology stacks and all of the choices that come within it. And if you think about that, it's incredibly complex. Right now, we live in a world where there is a huge skills shortage. You all here are a very, very precious resource right now. So we have to work out, how do we move forward? How do we deal with all of this when skills are a limited resource for us? It's highly risky. If you increase the blast radius, you naturally increase the risk. If you start putting more workloads into different locations, different data centers, you naturally have to focus more on how you're going to secure all of those things. And then you've got, it's resource intensive, goes back to the skill, and it's abundantly inefficient. We spend between $500 and $600 billion a year on the cloud, and up to 30% of that is wasted for many different reasons. Somewhere between 150 and $200 billion that we spend inside the cloud is on resources that are overutilized, over-provisioned, or simply not used, not cleaned up after. So how do we solve that problem? Some people will tell you the answer to this problem is, again, more VMware. This is not dismissive against VMware, but the answer is not more VMware. VMware is now just one of the applications that will run within this environment. You will run VMware alongside containerized, cloud native, enterprise, elastic. VMware isn't the purveyor of everything anymore. We don't run everything on VMware. It will be an important part of our worlds going forward, alongside a whole bunch of stuff that does not run in VMware. So the answer is not more virtualization. The answer, I think, to this problem that we're seeing here is standardization. I think the opportunity we've got to look for is how do we find services that can run horizontally across these layers that start to mean that we don't remove the capabilities, the opportunities, the innovations that people get access to, but we just make a decision to say, let's try and make certain things standard. And I think the first one you start with is storage. If you can make the way you store, protect, manage, encrypt data consistent, whether it's on premises or across any cloud, the problems that that solves for you are phenomenal. I think if you can start to create a layer where you're putting in application controls, you're putting in kind of infrastructure optimization and automation, again, the problems that that starts to solve, I think, is significant. And then it's visibility. Yeah, how do you look into this infrastructure and find out what the opportunities are, where there might be over-provisioning, underutilization, where there might be issues? And if you can do all of that, the solutions start to become clear, which I think is unified data storage. I'm not here to sell NetApp. You know who I am. You know my colleagues are here. But I think unified data storage that is available on premises and across any cloud becomes part of the answer. Intelligent services becomes part of the answer. And what I mean by intelligent services are things like security. I'm going to start this off with a disclaimer. Please don't do this. I'm going to tell you something, and just please don't do it. Not that any of you would, I'm sure. If you would, or if you wanted to, you could go and download the Tor browser. Many of you in the room will know about the Tor browser, the onion ring. It's effectively an untrackable browser. It was designed to ensure that you have complete privacy when you're using the Tor browser to access the internet, which means you can access some pretty seedy parts of the internet if you wanted to. Don't do it, but if you wanted to, you could. Now, with a little bit of Bitcoin, in those seedy parts of the internet, you will also find ransomware as a service. And some of these ransomware as a service sites are so sophisticated, they actually give you a user interface where it will tell you how many attacks you've launched, how many files have been encrypted, how much Bitcoin you've been paid, and how many more attacks would you like to launch. And the companies behind these pay tax. Because they're not hackers, they're penetration testers. And therefore, they're legitimate organizations. That means that we are now in a world where anybody can attack you. Anybody. And the attacks are getting more sophisticated as well. And now, we also have to start thinking of a new threat vector. Some of you may have started to see something which is steal now, decrypt later. Steal now, harvest later. A few of you may have heard of that. The current estimates are that by 2029, there or thereabouts, we will have quantum systems that are powerful enough to start to break current forms of encryption, particularly asymmetric encryption. So if we look at RSA, SHA-1, TLS, IPsec, SSH, all of those are considered extremely weak in a world where we have a quantum computer. That's all of the encryption we use for in-transit data. So the idea being, I'll steal your data today, and then I'll wait. And I'll wait for the quantum computer to come along that's powerful enough to be able to decrypt it in the future. And it's not that far away. If you are a military aircraft company, that's my background was aircraft, so it's a key interest for me. A military aircraft is typically 10 to 15 years in design, will be 20 to 25 years in service, and then will remain classified or top secret for a further 20 to 25 years after. That's 50 to 60 years where that data should be retained and kept as top secret. I'll steal it today, and I'll wait. And how long do you think it will be before we have a quantum system that is powerful to decrypt it? This won't be hackers. This won't be your mom and pop hacking shop. This will be state actors that will be looking at this. It is a very real threat that we now have to start to consider for anyone who needs to have data that continues to be secure beyond the next 5 or 6 years. And then we have to think about AI. And I talked a little bit about AI, the title of the talk was a little bit about AI. AI is a data challenge. 85% of AI projects fail. I don't know if that surprises you at all. 85% of the AI projects that we do today fail. And they fail for a whole variety of different reasons, but 2 of them are related to data. One of them is data access. And what I mean by data access is that we give somebody an AI project, but we don't give them access to the breadth of the data that they would actually need to make that project successful. So we set teams up for failure by not giving them the ability to actually take their AI and tap it into the breadth of data that could actually make that project a success. So many of these kind of siloed projects that people are working on either deliver very little value or are simply written off. So as we kind of think about how we're going to maximize the opportunity in this world of AI, data governance, breaking down silos, working out how do we put a data strategy in place before we embark on the AI project is absolutely key to it. And again, it comes down to standardization. What if you could have a single pane of glass, a single storage layer that runs across on-premises and cloud that doesn't have those silos? I bumped into a data scientist about 2 years ago, and they're a very interesting breed, by the way. But I remember talking to him, and he said, "Who are you and what do you do?" I said, "I'm Matt Watts." I said, "I'm the Chief Technology Evangelist for NetApp." And he said, "NetApp? Who the hell are NetApp?" So where do you go with that? You know, we're a storage company. Believe me, when you tell people you work for a storage company, you're the last person they want to speak to at a party. Maybe I'm a data management company. There's a response to that as well. Yeah, you and every other storage vendor, because everybody's a data management company. And I remember saying to him, well, we help companies build intelligent data infrastructures. And he asked, what do you mean by that? And I said, what if I could build you an intelligent data infrastructure that would allow you to take a snapshot that would give you a revision, a point-in-time replica or content of any data you use to train a model at a particular point in time? And he said that would be valuable. I said, what if I could clone data that consumes no additional storage such that you could have multiple scientists training in parallel? And he said that would change my business. I said, what if I could help you to do it consistently, whether it's on premises or across any one of the clouds, using any AI framework in the cloud? And he said that would fundamentally change the way I do business. Getting storage and data correct or right for AI has this huge, huge opportunity and impact. And it can be that sort of foundation for it. I've had to change this slide multiple times because I'm working for an American organization. So I've been looking in and around sustainability for many, many years now. Funny enough, that's not top of the agenda in the US anymore. So let's call it an energy problem. This year, we will create 175 zettabytes of data. Now that's every piece of data created by everything that can create data. That puts us on a path to create a yottabyte of data by 2030. There's, I think, 60% business people and 40% technical people in this room. So about half of you will know what a yottabyte is. The other half will be going, he's just made that up. I haven't, honestly. I didn't make this up. The next one's brontobyte, by the way. That's what comes next. This is 1 trillion terabytes. Let me make it really simple for you. That is the equivalent of every human being on the planet carrying 300 iPhones. That is the volume of data that will be created by everything that can create data. Now, there's not much we can do to affect that because we're not in control of all of those things. But let's put it into the perspective of what can we control. In Iceland, about 7% of your electricity currently goes to data centers. I don't know if you knew that, but it's an interesting stat. It's a bit of a scary statistic as well, because these data centers were built for the enterprise workloads. These were not built for AI. If you don't think it's going to get any higher, go and talk to the Irish. 21% of Ireland's entire electricity supply currently goes to AWS, GCP, Azure, Meta, X, and a sprinkling of others. And these are enterprise data centers. These were built with 5 kilowatts per rack. AI data centers, 150 kilowatts per rack, estimated to go to 250 kilowatts per rack over the next 1 to 2 years. Let me give you some context around what that means. In Ohio, there are 50 companies trying to build 90 new data centers in Ohio. The Ohio Power Company said the only way this can happen is if you pay us 90% of your estimated electricity use up front. Because that's the only way we can invest in the grid to be able to provide that amount of electricity. As you can imagine, Google and others didn't want to pay 90% up front, so they took it to court. It got agreed, 80. It's a win, I suppose. 80%, and it's been agreed, that's what will happen. Those 90 data centers at peak load will be estimated to consume 30,000 megawatts of electricity. That's the equivalent of 21 million households. That's double the population of Ohio for 90 AI-based data centers. The US currently has 5,500 data centers, but all the new ones being built are being built for this reason. So what does that mean from a storage perspective? That's what I'm interested in, storage and data, of course. That's what I can affect. The other view is that maybe 38% of the amount of data that we store, the amount of storage that we use, 38% of the power will go to storage devices. It's currently about 20. So what does that mean? Well, let's just use the current numbers. Let's go with the 10, but let's go with 10%. Let's say 10% of your future electricity is going to data centers, okay? 38%, let's go low. Let's say 3% of that. So we're about 3% of your electricity supply will be powering storage devices inside data centers. And I'm working on the lower numbers here, okay? 68% of the data we create and store is a gigantic landfill of crap that we do nothing with after it's been created. Single-use data, dark data, whatever you choose to call it, more than 2/3 of the data we create that is sat on devices that we are powering, we do absolutely nothing with at all. Which means, if we roll those numbers through, 10%, 3%, and then 68% of that, 2% of your country's entire electricity supply could be powering storage devices that are storing data you do not use. That's horrific. So I think there's a huge opportunity here. And the kind of opportunity is this. The first thing is we need to find the waste. We've got to start getting better at managing where is the waste inside our environments, and start with the servers. They consume the most power in the data center and are often the biggest candidates for where we actually waste resources. Let's analyze this data. The opportunity, if we could start to work out what that 68% of data is and do something with it, how much more could we achieve because of it? Then use the cloud providers where it makes sense. It's different for you here. You're mostly or nearly all renewable energy, but the cloud providers in different regions do offer a good alternative for companies that aren't using renewable energy. And then finally, what you do put back into the data centers, make sure it's the most efficient technology you can use. Don't let vendors start you at point 4 and tell you that their server, their sprocket, their widget, their network switch is going to save the planet because they are false prophets. Start at the other end and work back. If the opportunity to reduce energy is that big, putting more efficient storage in, that little bit there. So don't let vendors drag you to what it is that they do and convince you that that will solve all of the world's problems. It won't. So in all my time, a long time ago, this presentation started off as the third wave. And I don't always give this presentation. I've got a lot of different presentations I do, but this has been the third wave. And when you talk about the third wave, the very first question that people ask you is, what's the fourth wave? And now this presentation is called the fourth wave. So what's the very first question I get asked now? What's the fifth wave? That's really difficult. I'm part of a car club. I go to car meets. In fact, I have one this weekend, which I'm ridiculously excited about. And I went to a car meet a few weeks ago, and I was stood there actually with my brother, and we were chatting away, and this beautiful red Ferrari pulled up alongside me. And the guy jumped out and started chatting away, and he asked me, who are you, what do you do? And I said, Matt Watts, CTE, work for NetApp. And he went, oh, yeah, right. Moved on. And I said to him, what do you do? Looking at this beautiful Ferrari. He said, I'm in the army. I said, fuck me, they pay well. And he said, no, I used to be in the army. He said, and I came out of the army, I had a bit of cash. He said, and I decided I was going to invest in something. He said, and I spotted this funny little company called NVIDIA and decided to put some money in. and now I have a Ferrari. I thought, what a wonderful example of somebody who spotted a wave, but spotted it from an investment point of view. And sure enough, he's made a fortune out of it. So I'm not an investor, and I'm certainly not giving you investment advice. By the way, let me caveat this very quickly. But there are certain things that I look at, there are certain signs that I'm starting to see, which I think are indicators of what the fifth wave could be, and I've mentioned one of them already during this talk. We've been talking about quantum for a long time. You know, this isn't new. Bear in mind, we've been talking about AI since the Turing test back in the 1920s and 30s. And it's only been in the last few years that we've really seen AI unleashed. AI was democratized because of a little thing called ChatGPT. That was the moment that the programming language for AI became the spoken word or the written word. We now program AI by talking to it, which is staggering. And that's why it's unlocked it. That's why it became a wave. Do we have that moment for quantum? No, we don't. But it'll happen. Something will happen that will make quantum accessible to the masses. We already know that we've got a security issue we have to deal with. We can't push that out. We are going to have to start thinking about how do we protect our data as we look out over the next 5, 10, 15, 20, 30 years against a world where we have quantum systems. We can already do quantum transportation. That is linking qubits, which are the processing elements of a quantum computer, together and pass data across noisy networks. And we know that we're starting to see quantum computers with hundreds, if not thousands, of qubits. It is coming. You are going to hear a lot of noise about it. This year, the UN declared as being the year of quantum. April 14th is, I believe, Quantum Day. I hope you all have cakes and hats and a party around at your house. So there's a lot of noise around it, and I think it is something that's very interesting to look into. Thoroughly enjoyed being here. I wish I could stay longer. I'm literally walking off this stage into a taxi. But I'm going to just leave you with a sort of a final thought. I hope you've taken something away from this, even if it's maybe an idea that you hadn't thought of. And that's the thought I'm going to leave you with. As I walk off this stage and I jump into my taxi and I head out towards the airport, there's a couple of things I'll be thinking about. The first one is, what didn't I say that I should have said? That's usually quite a long list. What did I say that I shouldn't have? That's usually a longer list. The Ferrari, and fuck me, that's a nice car. That's probably one. But I do it for one simple reason, that I always take this as an opportunity to improve. Every event I go to is an opportunity for me to do better next time. So I will think of one thing because of this event that I'll do because of this event, and I'll try and make sure that I do that for the next time I do a talk. And that's what I want to ask of you. Honestly, myself, the team at Sensa, we can't thank you enough for taking time out of your busy schedules to actually join us here today. It means so much to all of us. But if you leave here and do nothing, why did you come? I could have sent you the slides. And that's my ask. Please, as you go through the rest of the day, you're going to see some fantastic people, some fantastic presenters, some very knowledgeable, smart people. Think of one thing you'll do because you were here. I frankly don't care if it's business, personal, technical, I don't care. But think of one thing. Because at some point in the next month, 3 months, 6 months, 12 months, you'll do that one thing. And when you do, you'll look back on this event and you'll think, that was a really good use of my time. And that's the only reason we do this stuff. Thank you very much. Enjoy the rest of the event. Thank you.